back in time. Does that sound like fun? Kind of adding to what Brian did with the periodic chart. Today we're going to go back and visit my good friend Dmitry Mendeleev, who kind of came up with the idea of the periodic table, as he called it. And so what you have here is Dmitry Mendeleev's periodic table that he came up with in 1869. And what we're going to do is go back in time, because this is a brand new idea in 1869. We're going to go back and help him decide if it's a good idea. Because here in the 21st century, we know it's a great idea. Everybody uses the periodic table. But back then, it was just a new idea, and he wasn't sure if it was going to be useful in chemistry. So what I want you to do is you've got all these elements, and I want you to arrange them according to what Dmitry Mendeleev had for a table. I'll get you guys a copy of the table. If you guys can put those all in order. Sure. So these elements have properties on them, okay? Because the chemists in the 1800s were able to measure a lot of properties about the elements that they had. Okay, so properties in periodic tables. There's two vocabulary words that we're going to introduce to them. So properties. Does anybody want to give me a definition of what property would mean? What would be a property? You thinking?
It's the intrinsic. It's like a physical characteristic.
Characteristic.
Like that, yeah.
Anybody else? Property. What is a property of an element? Weight. That's a property. Okay, so they're like descriptive terms. So Dmitry came up with this periodic table, so his idea was that when he looked at all these properties, these characteristics that he measured, he thought he was observing trends. That was the new idea. I should have stressed that at the beginning. His idea was that he was observing periodic trends, and he could arrange all these elements in a table that explained his periodic trends. You guys getting that?
Yeah.
Okay. So what we're going to do today is we're going to set up the elements, the known elements that they had in 1869, in Dmitry's periodic table, and we're going to look for those trends, okay? So we're going to see if we see the same trends that he saw. And then once we have looked at trends, periodic trends, we're going to decide if those trends are good predictors, or rather the properties. We're going to see if the properties are good predictors of periodic trends. Does that make sense?
Yes.
Got a lot of P words there. So on your element cards, you have a bunch of properties. Let's talk about the first one first. That's the easiest one. The atomic number. Does everybody remember what the atomic number is of an element? Somebody knows. The atomic number of an element.
The amount of protons.
Protons, right. Number of protons. In 1869, they didn't know what a proton was. But the atomic number is also directly related to what?
The electrons?
Neutron.
Kind of.
Mass.
The mass, right. So they were able to weigh the elements, the atoms. Good job, Renee. So the atomic number at that time was kind of the mass or the size of the elements. So they were able to arrange their elements from smallest to biggest. And that's mostly what they did. But if that's all you have, from smallest to biggest, how do you end up arranging all your elements?
One big line.
One big long line. And that's not very efficient. And it also, as we know in the 21st century, doesn't talk about the periodic nature of elements. So when, let's see. You guys done with this?
Yep.
Should have printed out another one. So what I want you to do is look for trends, periodic trends. Let's talk about that word, periodic trend. We'll break it up into two words. Periodic. What does periodic mean? Periodic trends.
Different times.
Somebody have a
Repetitive.
definition for
Repetitive.
repetitive? Sure. Repetitive, periodic is repetitive. Okay, what's a trend in anything?
Pattern.
Trends, a pattern, any particular kind of pattern? A trend.
Or a movement.
Trend, yes. Sounds kind of like.
Particular direction.
A direction, exactly. Looks like Katie was about to say it. So trends. So we're looking for trends because our friend Dimitri, he thought he saw trends. Now, which direction can a trend go in? So this is a table. What directions could we have? In the table, which direction can you go?
Right to left.
Right to left? Any other directions?
Down.
Up and down, right. It's kind of like a spreadsheet. I don't think they had spreadsheets back then. But so I want you to look at for trends going up and down or back and forth. So look at each property on your element cards and see if you can notice the trends that Dimitri saw. Okay? So some of the properties are going to show strong trends and some of them are going to show not such strong trends. And when you think you're starting to see observe some trends, if you do, the next part, I'd like you to go for each property and tell me if that property, like atomic number, that's an easy one. Tell me if the property is a good indicator of a periodic trend, a medium indicator of a periodic trend, or a poor indicator. Does that make sense? It's kind of a lot there. So the atomic number, that's obviously a pretty good indicator, isn't it? Is everybody following that? I know there's a lot going on.
Trying to order this.
H-E-N-E-A-R.
It'll go in order.
You can use the numbers, put them right in order. If you got one in the right place, the one with the next number obviously goes next to it.
So I'm sorry, you're.
And there's a gap here.
From left to right.
You can leave a little bit of a gap.
Number. Atomic number for
Salad, salad, salad.
with the density.
So these guys notice, yeah, there's a little bit of a gap here. Is it here? Or is it here? It's kind of confusing.
So do we all have the same
They all have the
letters?
same letters?
They should.
Elements?
Oh, okay.
28, right? Are there 28? 2, 3, 4, 5, 6.
Looks like your state.
Maybe I counted.
Oh,
Well, I just didn't know,
was
like, I didn't know if
wondering
they
looked
had
the same.
this.
No, there's some gaps here.
Yeah.
So remember, this is 1869. Not all elements
Yeah.
have been discovered.
Oh, okay.
Oh, good enough.
Or made up.
And here's one of the most important scientific concepts that they don't teach in science books, guys. Sometimes what you don't know is the most important
I think
thing
we're supposed to see
to realize.
this way and this way.
So Dmitry Mendeleev knew that they were measuring a lot of things about elements.
Very reactive.
They knew that there were things that they didn't know.
But he didn't know back then that there were these gaps. Did he know there were gaps?
There were, when he placed them in tables,
Yeah.
there were gaps in,
Oh,
That's
okay.
interesting, because here,
Okay. So,
these are, represent gaps in his knowledge.
okay. So he knew there were gaps in his knowledge.
Yes.
Yeah, he knew that they were there because of the way it's set up.
took off.
Oh.
Later on, he actually predicted other elements would be described and where they would fit in the periodic table.
Oh, okay.
So if you are starting to get some idea of some trends and which ones,
That goes.
which properties are good
Oh, no, it doesn't.
predictors and which ones are poor, I'm gonna give this group some unknowns.
Ooh.
Here's some unknowns.
I like that.
So our real chemistry guys know where this is going. In chemistry, you spend a lot of time discovering the unknowns.
So why don't we put them like very reactive together?
So based on what you have observed about periodic trends, whether they're good periodic trends or not so good periodic trends, try and place the unknowns, and we'll see if this organization is a good idea. And if it is, we'll tell our friend Dimitri that it makes sense, that it helps.
Well, like this is,
Sorry, I'm gonna
What do you guys
cover
this
so
is
we can
point
see.
Oh,
0.012.
yeah,
You're right.
So I was trying to go, density seems to be, go up as it goes down.
Have you found any one property that seems really strong?
Besides the density, oh, you mean the atomic number going across?
The unknowns have no atomic number. That
Right.
would be too easy.
Yeah.
Oh, you know what? But
Is it?
Some of them are strong in one direction and not strong in another direction.
Could be over there. The trend for me is that way.
You think this should go this way?
Yeah.
Based on,
To get that it's a gas.
it's a gas. Are there any gases over here?
No, they're solids.
These are gas.
And then here the
These are solids.
So he's saying that there's mostly gases here, so based on that, he's gonna start on this
Over the side,
side.
yeah.
So now we need to go
Oh, this is a gas.
up and down.
23, 2.
How about density? Does density tell you anything?
Yes, density, the smaller's on top. Smaller densities on top.
Was density a good
Well, that's
indicator?
helium.
Did you look at density across a row? Density, we got
No, I just
500.
went, that was my trend going up,
Density, we
down.
got 1. Density, we got 2. Density, we got 2. And then it drops off the board here.
Yeah, but going down, I was reading down for density to try and place it in a vertical.
So going up and down, is this a density a good indicator?
Up, higher density.
Ionization.
Most of the time, all of the time?
The ionization energy.
Some of the time?
Seems to go down, farther down.
What I'm trying to do is develop confidence in this. This is a new system.
Yeah.
I think you're right, I think that was there.
I think you're right.
4, yes, it goes up on all of them.
Okay.
The density
So based on that, with this,
That's weird though.
just try and place it in a row and see if it fits in, based on density. If it,
Then density.
if you don't have a lot of confidence, go to the next one.
He said to leave room in the middle.
How about ionization energy? There's a big number.
2999. I was like, over here.
What do the ionization
Maybe that's
numbers?
just there.
Well, no, because it would have to go above that
Density.
one.
But 13's below
21.
that one. Isn't 13 between these two?
For ionization, but ionization doesn't go in.
So this has
Oh,
a,
I see.
is the ionization energy
Density.
predictable?
There's no ionization.
24, 21, 15, 12.
Oh, it's going down.
So where would 13 fit? If it was in
Yeah,
this
you're right,
column?
you're right.
So if it was in this column, it would fit here.
I was never a
I
chemist.
was still looking at density.
Yeah.
But isn't wouldn't it fit there for the density
Does
too?
does the density make sense?
Yep,
Three.
that makes sense.
Ionization
One.
energy.
Yeah.
So very small numbers?
Yeah.
That seems like.
Okay.
Yeah.
Okay.
So what would you say about the ionization energy as far as a predictor? Is that a good predictor or poor predictor?
Yes.
Yeah, I thought it was pretty
It
good.
is pretty good, yeah.
Okay.
Across the.
Try and work on some of the others. How are you guys doing over here?
Ionization, 17.
Okay.
Okay.
Not necessarily. Yes, we are.
No, do you have the other unknowns in there?
Yeah, we put in, we have our 3 unknowns here.
Because of the
Okay, are you cheating?
reactivity that you just
No.
mentioned.
Okay.
I don't think so.
But you know some chemistry, right?
I know a little bit.
Okay,
You were a good teacher.
So are you finding out anything about these periodic trends? Like if a particular property is a good trend or a bad trend?
1.96 grams.
Does that make sense? Do you guys understand that part? Here's an unknown.
This is not high enough for that.
So physical state, the top one, other than the atomic number. They discovered that if it said gas, almost all the gases were on the side of the chart. So when they found a gas, they just went over there and fit it.
Yeah, we kind of did that with the solid.
And then with, so this one's a solid.
That's,
So it's probably not in this corner. So density, what does density do as you go up and down? So less than, so this is a small number, 1. What's the density?
15.
Another very small ones.
No,
These are all
13.
small numbers. Do they seem to make any sense?
so no more than 2.
0.3, 0.8, what's it doing?
Tom, we got about 2 minutes.
Okay.
Kind of gets this route.
It goes 8,
Yeah, we
11,
figured
and
this
14.
Okay. Try this bottom one, ionization. They thought it was a pretty good indicator. Let's see if you can
Maybe,
put
maybe.
Right, that's how I
that.
read
Are you guys
it.
coming up with any answers?
But my question is if we do this
Have you put the
one,
unknowns?
the top,
We got unknown number 1
here, so they send it to me.
Based on,
So like if you look at this line.
was there any particular property that you thought was a strong indicator for that?
The other way. Like these
Well,
all-
it's reactive, so all of these were reactive.
Okay. How about over here? Were there any reactive elements over
So
here?
I guess we're just looking at it this way.
Yes.
Solids? Yeah.
Okay.
Okay, so this is a solid. So it's 10.36.
Okay, so that's why you put number 2 here.
No.
Is this where you wanted it, number 5?
That was the last one we were working on.
Okay.
So we were thinking it had to be over here because it's reactive. And we were looking at that, we were trying to fit it in based on.
Tom, might want to move into wrap up.
Okay. Okay, so what I want you to do, since we're running out of time, is take this home and you can continue working on it. And for tomorrow, make a claim for at least one of the properties, density, melting point. Take one of them and look at it really closely and tell me if a particular property is a good indicator, a medium indicator, or a poor indicator of a periodic trend. Okay? Tomorrow, thank you.